How to read a resistor. Resistor is a component that has certain amount of resistance used to pulse or limit the flow of electric current. Recall that in a previous video we looked at resistance of a resistor to be dependent on the length, resistivity, and its cross-sectional area. You can find that in an electricity series video titled Resistivity and Conductivity. Basically, resistors are categorized into two classes. The first is the linear resistors, while the second is the non-linear resistors. For the linear resistors, they are resistors whose value changes with applied voltage and temperature. Linear resistors are grouped into two. One is a fixed resistors, and then the second is a variable resistor. Fixed resistors are resistors that have specific value. In other words, they can be changed. And the types of fixed resistors include the carbon composition resistors, the wire wound resistor, the thin film resistor, and the thick film resistors. For the carbon composition resistor, they are made of mixture of granulated carbon or graphite. The downside of this resistor is that they are less stable because of the temperature coefficient, which is very high. Also, they make a slight noise as compared to other types of resistors. For the wire wound resistors, it consists of an insulating core or rod, which is made of porcelain and is wrapped around the resistive wire, which is tungsten or magnesium. They are commonly used in sensitive testing and measuring devices or equipment like Wheatstone bridge. The downside of this resistor is that it is expensive and can be used in high frequency equipment. The thin film resistors. They are made of very thin conducting material layer overlaying an insulating rod, plate or tube, which is made from a high quality ceramic material or glass. The types of thin film resistors include the carbon film resistor and the metal film resistors. For the carbon film resistors, they are resistors which consist of a very thin resistive carbon film overlain around a rod made of high-grade ceramic material. They are widely used in electronic circuit because of their stability, negligible noise, and wide operating range as compared to solid carbon resistors. Metal film resistors are same in construction as carbon film resistors, but resistivity film is metal glaze, which is a mixture of metal and glass or a mixture of metal oxide. They are used where stable and low noise level is important. The thick film resistors. The production is similar to that of a thin film, but the difference is that the resistive material is thick instead of being thin. The types of thick film resistors include the metal oxide resistors, the ceramic film resistor, and the fusible resistor. For the metal oxide resistors, they are made by oxidizing a thick film of thin chloride on a heated glass rod. They have a high temperature stability, low operating noise, and can withstand high voltage. For the ceramic film resistors, it consists of a carbon or metal alloy layer wrapped around a ceramic insulating material fixed to its ceramic metal, which is called the ceramic. Since the resistivity is independent on temperature, they are stable under high temperature. The fusible resistors, they act like a wire wound resistors. When a circuit's power rating is above the specified value, then the resistor breaks or opens a circuit, so they don't only limit the current, they also act as a fuse. They are widely used in TV set, amplifiers, and other expensive electronic circuits because of their ohmic values less than 10 ohms. For the variable resistors, they are resistors whose resistance value can be changed manually through a dial, a knob, a screw, or a slider. They are used in radio receivers for volume and tone controls. They include the potentiometer, rheostat, trimmer resistors. For the non-linear resistors, they are resistors whose resistance tend to vary with change in temperature or applied voltage. They do not obey Ohm's law because they do not change according to it. The types of non-linear resistors include the Thermistors, the Resistors, and the photoresistors, or the LDRs. For the Thermistors, they are resistors whose value changes with temperature, that is, the temperature changes the flow of current through the resistors. The types of the thermistors include the negative temperature coefficient thermistor, which is the NTCs, and the positive temperature coefficient PTCs thermistors. For the negative temperature coefficient thermistor, they are made of cobalt, nickel, iron, or manganese. Its resistance increases when temperature decreases. It's used in temperature sensing instruments or current limiting. The positive temperature coefficient thermistors are made from lead, strontium, or barium titanate. Its resistance increases when its temperature increases. They are used in overcurrent protection, self-regulated heater, or time delay. The varistors are voltage-dependent resistors. The applied voltage through the resistor changes the current flowing through it. They are used in eliminating high voltage transit. They protect circuit from destructive voltage spikes, like when voltage increases due to lightning or line faults. The light-dependent resistors. The light-dependent resistors, or the LDRs, or the photoresistors as most times can be called, are resistors whose resistance changes with light intensity. They are made from special resistors called the photoconductors. Examples include lead sulfide. When light falls on these LDRs or the photoresistors, their resistance is increased. They use a flame or smoke detector, the leading burglar alarm, the door openers, light meters, street lights, photographic devices, your smartphones, and so on. The surface mount resistors. The surface mount resistors are part of SMDs, as the surface mount devices. They are very small rectangular electronic components using SMTs, that is surface mount technology. You can find them in your mobile phone, PCs, and many electronic systems. Application of resistors. Resistors are used for current control and limiting, as shunting ammeters, as a multiplier voltmeters, to control temperature, to control applied voltage, for protection in electronic devices, e.g. fusible resistors, in home electrical appliances like heaters, pressing iron, and in laboratories and many industries. Resistor color code.